Sir, all students joined, sir. Only 25 students joined. Hello.
Yes, sir. 25 students joined, sir.
Still, we will wait. Please inform to them, sir.
Okay, okay.
Yeah.
Sir, Srinivas, sir. Sir. Sir, Srinivasu, sir.
Sir, yes, sir.
Sir, you please start the program, sir. Actually, today
Okay.
Moharram festival, sir.
Yes, sir, sure.
Maybe most of the students and the faculty members they participated they are celebrating this festival. So you please start the program, sir.
Okay, sir. Okay, sir. Only 27 students joined, sir.
Yes, sir. No problem, sir. You start, sir. Please start, sir.
Okay, sir. Sir, my screen is visible, sir.
Yes, sir. Visible, sir. Yes, sir. Visible, sir.
1 second, sir. My screen is visible, sir.
Yes, sir. Visible, sir.
Yeah. So, welcome back to second day session of ontology-based data access. My dear students and faculty members, a warm welcome to 5-day international training program on ontology-based data access. That is the short form of OBDA. Yesterday, I have explained the fundamentals of ontology-based data access, what is ontology, and what are the examples of ontology based access, and what are the foundational concepts, and I have explained. And so ontology is a sub branch of data mining, and data mining and ontology is a sub branch of databases, and that is also a branch of artificial intelligence. So, ontology is the study of relationship between the data from the past data and current data and future data. And finally, it can refer to the formal representation of knowledge or information. That is our main goal to achieve meaningful data, interested analytics. And the last class we have discussed about the syllabus of ontology based data access. And today I am going to explain what are the major concepts of ontology based data access and why it is so important in real time environment in order to implement various case studies like healthcare data analytics, retail industry, and defense sector, and any other huge domains of weather forecasting and various real-time case studies. So why ontology is used an interface between users and data sources? So ontology is a relationship that is called interface between users and data sources. So to see why ontology is used as an interface in between users and data sources to provide a unified view of heterogeneous data sources, to provide a unified view of heterogeneous data sources like different databases, different data sources, like where we are getting health data from hospital, real-time hospital environment, and retail industry, weather forecasting, and NASA data, and retail industry, and weather forecasting, traffic data. So that is the interface between users and data sources. And to allow users to query data using domain specific terms, like domain is a retail industry. What are the terms? You can see support and confidence. What are the items and what are the frequent items in the supermarket, and what is knowledge, what is data, what is information, what is database. We are seeking to extract knowledge from the scratch. What is KDD, what is data warehouse, what is data mart, database, and data cube, tables. This is the relationship between data and information and database. This is the domain specific terms in terms of extracting knowledge or information. Okay, so that's why we are using ontology based data access in order to implement real time applications. See, yesterday I have given one assignment, my dear students. Have you done this assignment? Please respond, anyone. Explain ontology of computer science. Hello. Please respond.
Students, if you know the answer, please raise your hands.
Yes, please. See, 33 students joined. They are wonderful students, computer science and information technology students. Have you done? Okay. If not done, I will explain once again how to create mappings and query of given ontology of computer science engineering. How to develop a assignment task. Okay. Shall I explain? Okay, listen carefully. So, computer science is nothing but study of computer related information and applications by using various programming languages like Python, Java, C, C++, Ada, Smalltalk, and you can take a Scala from Spark. Various languages we are using in order to maintain the relationship between computer science jargon and terminology. See here, you need to know what are the key terms. What are the key terms of computer science? So first one is a programming. Programming is nothing but collection of instructions. Instruction is nothing but set of rules. We have a various types of programming languages like web programming languages. We are using HTML and XML and various web technology programming languages we are using. Okay, cascading style sheets. Various web technology programs are using to develop web related applications. Then system oriented programming languages like C programming, Lisp, Prolag, Pascal. These are the system related programming languages. Then intermediate languages like C++, Python, Java, these are the object-oriented programming languages. And applied programming languages, in order to solve real-time mathematical applications, we are using some applied programming languages. This is about one relation and terminology of programming. Then coming to theory. Theory is one of the indexed term of computer science engineering. We need to have knowledge on coding. Coding is nothing but in set of instructions such as in Python programming, C++, Java, C, Lisp, Prolag, Smalltalk 80, Object Pascal, etc. Algorithms. Algorithm is a step-by-step procedure to solve a particular program or problem is called algorithm. Algorithm sometimes call it as a pseudocode, set of instructions which can understand by the humans. English, high level language with English like instructions, that is called a algorithm. There are numerous algorithms are using to solve particular scientific and logical programming languages. Then theory of computation. Theory of computation, how a particular program according to the instructions we are developing with the help of Turing machine and push down automata and various instructions we are using in the motherboard level, and we are using some theory concepts in order to implement any real time applications. Then coming to the logic. Logic is a simple steps to solve a particular mathematical problem or any scientific related problems. Suppose I would like to solve a problem like a swapping of two numbers using third variable. What is the logic? I am using third variable temp. Temp is equal to A and A is equal to B. B is equal to temp. This is the logic of exchanging of two variables by using third variable. Same logic can be implemented without using third variable. How do we implement in C programming? Python, Java. Okay, see the logic. You can take two variables or input variables A and B. Now, my aim of the program is to exchange the variables values such as A is equal to A plus B, B is equal to A minus B, A is equal to A minus B. You can check. This is the simple logic we are using, swapping of two variables without using third variable. Then operations research. Operations research is it gives us what is the optimization technology of the solving real time problem. What are the OR related inventory problems? Operations research on simple and optimization algorithms, optimization techniques we are using in order to solve real time applications. Then a third jargon of computer science is artificial intelligence. Artificial intelligence is nothing but intelligent behavior in a machine. That is called artificial intelligence. Like humanoid robots, best examples. Asimo and Sophia. Asimo and Sophia are the humanoid robots, and Sophia recently took the citizenship of Saudi Arabia. That is a humanoid robot. So there are terminology or jargon of artificial intelligence is the first one is expert system. Expert system is a one of the major concept in artificial intelligence. We are developing if then rules and maintaining a database based on the if else and else if and switch. These are the conditions, constraints we are using to develop if then rules and maintaining a database is called expert system. Then mission translation. Compiler is a program, it translates high level language to low level language. That is called a mission level language. So mission translation happening while compiling C programming language. So, not only C programming language compilation, I don't know Tamil, but I want to translate by using translators. So, by using translators, I am speaking in Telugu, it translates into Tamil by using machine translation. That is also one of the intelligent based application that relates to linguistics. Study of different languages is called linguistics, that comes under artificial intelligence. The way I am explaining all the terms and index terms, keywords are related to artificial intelligence. That is the relationship between scratch to extracting knowledge, the way we are extracting all the terms. That is called ontology of computer science. Then recognition images. By seeing face recognition applications using PCA technique. PCA is a principal component analysis technique. I'm translating, I'm using input images, 75 images, 75% images are training data set, 25% of images are testing. Now I'm using testing one image, and we have stored all the features of images in the database. Features like the forehead distance, the distance between mouth and nose, moles on the face. These are the constraints we are maintaining in the features in the database. Now I'm giving a new image to the system. My system model has to predict whether it is a Narendra Modi or not. That is called a face recognition application by using principal component analysis. That is called a recognition images. Then computational linguistics. Just now I have explained study of different languages is called a linguistics. So that is called a mission translation or language translation. I don't know Chinese. I would like to convert English to Chinese, Chinese to Telugu, Telugu to Tamil. That type of ontology is related to computational linguistics. Then modeling reasoning. Model is nothing but simplified version of the reality in order to represent the data and knowledge in the form of formal representation or information through diagrammatic representation or any visualization diagrams. That is called modeling with reasoning. What is the reason behind I am using particular notations of a diagram? This is a artificial intelligence ontology of computer science. Then see the left side bottom, information systems. Information is a study, processed data is called informations, and information systems related analysis, optimization, search, storage, and structuring. So what is meant by analysis? Analysis is a one of the step in SDLC, software development lifecycle. Whatever the application you have implemented and you are analyzing the results, how many items are correctly classified by using classification technique, and how many items are not classified correctly, that also we are doing analysis by using confusion matrix. Then optimization. Optimization gives us the best algorithm, best technique, best tool of any real-time application. Then search. Search is one of the technique in information systems. I would like to search particular student, Ramesh, is presented in your class or not. I'm checking with the database with his ID number. So I'm searching by using techniques like linear search, binary search, Fibonacci search. These are the searching techniques we are using in information systems. Then storage. Storage is one of the component in computer science engineering. So there are two types of storage mechanisms: temporary storage and permanent storage. So if you are using RAM, the data is stored in temporary. If you are using a ROM, read-only memory, the data stored in permanent. Then structuring. Structure is nothing but you can call it as an architecture, which comprises software and hardware components and the connections among them. It is called a structuring. So there may be a software architecture, computer architecture, depends on. Okay, depends on the application, what type of application you are developing. There is a proposed architecture is presented. Then equipment. Equipment is nothing but infrastructure, maybe computer, maybe server, maybe data center. So computer is a electronic device which takes input and process it and gives the output. And a server is a physical equipment which is a special computer having a high computing configuration. So like RAM is 1 terabytes and memory is 1 zettabyte. That is called a server. Then data center. Data center is a collection of integrated high computing servers at one place is called a data center. Data center is a backbone of cloud computing. Cloud computing is an internet-based technology. Without internet, we cannot perform any service-based application or internet-based application. That's why every organization moving towards cloud computing. And data center and virtualization is the backbone for cloud computing. So cloud computing is a simple formula 543. 5 characteristics, 4 infrastructure models, and 3 services. 3 services are software as a service, and platform as a service, and infrastructure as a service. Then 4 infrastructure models like public cloud, private cloud, and hybrid cloud. Then 5 characteristics are OBR square M. O stands for on-demand computing, B stands for broad network access, R stands for resource pooling, and one more R stands for rapid elasticity, and M stands for measured service. That is about equipment that is related to hardware. Then comes to the networks. Network is a interconnection between the computers or servers or high integrated computing servers in the fashion of local area network, wide area network, metropolitan area network. That is called networks. We have 3 types of networks: LAN, WAN, MAN. Then this is about the complete ontology of computer science. My dear students, now I am going to stop here. I would like to ask queries. Understood?
Yes,
Please,
sir. Yes, sir. Yes, sir. Understood, sir.
any queries from the audience, participants, please. See, this is one-way communication. I don't like. If you
Sir,
ask me queries, then I can respond with the answers.
sir, I
If
have some doubts, sir.
yeah, yeah, please, sir, ask me, sir.
Sir, where we use this ontology, sir?
Sir, wherever data-related database domains are presented, we are using a ontology concept for ontology-based data access. Suppose in a suppose in a healthcare domain, you can use a healthcare is a one domain and related terminologies like hospitals, okay, and electronic health records, patients database, doctors database, and real time health database, and types of diseases, and the complete information, index terms, key terms related a particular domain, healthcare domain, that there is a ontology. So ontology refers to acting as an interface between user and data access or data resources. That is called ontology based data access. Very
So,
good question, sir.
sir, what is ontology exactly, sir? Is it any algorithm or a technique for accessing data?
Yeah, yeah. Algorithm.
Algorithm, sir.
Ontology is a relationship between users and okay,
Yes, sir.
and users I mean the relationship between users and data sources. That's why it is called ontology. So why we are using data Why we are using ontology, I have explained already. Please see here, to provide a unified view of heterogeneous data sources. Heterogeneous data sources is nothing but different types of data sources we are taking and performing and solving a particular application. That is called ontology. Ontology is a relationship between scratch data level to existing, being, and solving the real-time applications in order to extracting meaningful knowledge or information in the particular domain. That is called ontology. Very good question, sir. Any doubt?
So actually, for accessing data, we have so many softwares. Even in Excel sheet also, for
Yes,
accessing
yes,
data, we have some formulas. Using formulas, we access the data, and we have DBMS.
yes.
So in those softwares also, we access the data. But
Correct,
what is
correct,
the greatness of ontology
correct.
on
Yeah.
behalf of these
What
softwares?
may I know your good name, sir?
So I'm Shankar sir, CSIT
Shankar, very
faculty.
good question. I'm giving the answer. Please note down. See, your sir asked the question, how many ways of accessing? We have a relational database tools like SQL, MySQL, Teradata, DB2, MS Access. We are accessing the data with the help of those database languages. Okay. Now, there are non-relational database tools like Mongo database, Hive database, HBase database, Scoop, and Scoop and Cassandra. These are the non-relational database tools. These are called NoSQL. In order to access audio data, video data, and XML data, and HTML data, and SQL, any kind of audio, video, animation database, speech recognition application, face recognition application. There are easy tools and data access methods and techniques are available. Related terminology applications. Why? In order to develop unified application from the different types of data sources. That is the reason why we are choosing ontology based domain data access. Yes, sir, you understood?
Oh, yes, sir. So,
Without schema, sir,
uh,
without schema, we are accessing audio, video, kind of database related information. That is the greatness of ontology based data access. See, if you are using relational databases, there is a schema, there is a table, there is a relation, and based on that relation and table, we are creating the tables, and a collection of tables is called database. Whereas non-relational databases like Mongo database, Hive HBase, there is no schema, there is no relation, there is no, you can call it as a procedure. But we are accessing the audio data, video data, image data, YouTube data, and streaming data without a schema. That is the greatness of we are accessing data accessing through ontology based. Sir, you understood?
yes, sir, understood, sir.
Very good question, sir. Next, my dear students, please ask me, have you done homework on the next topic like information technology I have given? Anyone? Any chat box, any query? Please, let me see. Nobody is giving in chat box. Why? What is the reason? You don't like to ask any queries? Girisha, please. Please unmute yourself and ask the query, please.
Girish.
She has raised a question, sir.
Okay, sir, I'm giving permission.
Please. Yeah, Girisha. Wait 1 second. I am unmuting Girisha. Where is Girisha?
Grishma,
Ah,
please unmute yourself, ma. Grishma.
Grishma. Are you understanding? Where is Grishma, madam? Please unmute, madam. I am not finding. Where is Grishma? Yeah. Shankar sir, please unmute them.
That student left the meeting, sir, it seems. Sir,
Why?
but one more, sir, asking doubt, sir.
Yeah,
Satish,
yeah,
sir,
please,
asking
sir.
one doubt, sir.
Sir?
Satish, sir, our CSIT faculty asking one more question, sir.
Yeah, please.
His question is ontology comes under which domain?
Yes, very good, sir. Wherever data is presented, it is related to databases. The database is related to data mining and data warehousing, and the extension goes to data, even data science. And in order to solve applications like real-time healthcare and any kind of applications by using machine learning, deep learning, artificial intelligence, all these comes under data science. I can say it as right now. Right now, this ontology also comes to the in data science, because web related applications also we are solving, and database related applications also we are solving, and any real time applications like healthcare domain, insurance, bank related application, retail industry, NASA applications, and weather forecasting application, wherever data is presented, database related applications we can solve very easily. Ontology is related to data mining, data warehousing, and data science, and intelligent kind of applications we are developing, it comes under umbrella of artificial intelligence. You understand, sir?
Yes, sir. Sir, one more doubt, sir.
Yeah, please ask me as many as doubts so that I
Social
can
media,
clarify, please.
social media apps like Facebook, Instagram, and
Yes,
commercial websites, Amazon, Flipkart, will they
yes,
use this ontology for their data
yes.
access, sir?
Yes, very good question, sir. I would like to clarify your doubt. Suppose you are accessing Facebook data, so there is a relationship between all the nodes. Node is nothing but user. How many number of users are aeronautics engineering students are presented? I would like to find out CSIT students. How many Facebook users are in one network? That is graphical representation ontology. So there are terms like node and server. There is a relationship between server with all the clients in a web related relation ontology. So there are special methods to access graph based mechanisms, graph based applications such as Facebook, Twitter, and WhatsApp. So, very good question, sir. Any kind of social networks, any kind of health related applications, there are very good data access method related to particular domain in order to access the audio data, video data, graphical representation of data, etc. Very good question, sir.
So
Any
is
other queries?
is there any other technologies other than this ontology
Yeah,
for
yeah.
the
I'm
data
going to
access, sir?
explain tools and techniques in the last slides.
Okay, sir.
Okay.
Okay.
Yeah. Any other questions, my dear students?
No, 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 sir.
No, no other queries.
Yes, sir.
This subject is presented in your second year syllabus, sir.
No, sir. Ontology we don't have.
Okay, because this is one kind of data mining and database and web related applications comes under artificial intelligence, sir.
Okay, sir.
Yeah. So, my dear students, now I would like to explain one more ontology of information technology. So, what is meant by information technology? Can anyone define? Please unmute yourself and give me the exact meaning of information technology.
Sir, the information technology they play the key role to share the data. So,
Perfect. Perfect. Please listen. Information is nothing but the processed data. Technology means application of science. Information technology is a branch of computer science. Computer science is a branch of artificial intelligence. We are solving intelligent based applications in the domain of information technology. The relationship between pairs of concepts like computer science and the knowledge, domain, reasoning, relationships, computers, web technologies, okay, databases. what not, related to networking, all sort of domains we are covering in the information technology. That's why we are developing a mapping. This is called create mappings. Mappings of ontology of information technology. See here, we are finally find representing knowledge. That means information. By using ontology, you need to find out a domain of information technology. So in information technology, we have domains like databases. It's a one kind of important term, and one more is a networking. Okay, databases is a one domain, and networking is a one domain, and natural language processing is a one more domain, and you can call it as a mathematical applications in one domain. We are solving all together in information technology, which is related to intelligent kind of applications. That's why we are explaining ontology of information, I mean information technology, through artificial intelligence techniques, statistical techniques, machine learning techniques, and deep learning techniques. We are solving real-time applications. Whenever you would like to develop ontology for information technology, you need to check what is the domain. Okay, so description of domain you need to understand. Then what kind of knowledge we are representing. Then you need to see the information science. What is the subject of information? Then whether this in IT is a subject of computer science, and what IT contains set of concepts like databases, networks, and mathematical concepts, and application, real-time applications, and mathematical related concepts. Then it contains a set of concepts and concepts, and it contains relationship. So IT is a related branch of computer science and as well as electronics engineering. So closely related. And by default, civil engineering, mechanical engineering, electrical, once they graduated in their respective domains, still they have a chance to become a software engineer. The background knowledge is they have one programming language like Java, Python, or C, and they know one database language called DBMS like SQL, MySQL, and they know one interface operating system called they know Windows or Linux operating system. That's why they are eligible to work as an IT engineer. So this is the way we are developing ontology of information technology. Any doubt, my dear friends?
No, sir, you carry on, sir.
Okay. So this is the way you have to develop. So I'm expecting tomorrow. Tomorrow again I'm taking a class for you with the practical session. Ontology of computer science, how I have prepared. Same way you can prepare for information technology. This is the way you need to understand. And okay, what are the domains are related to information technology? So it supports reasoning about a particular concept. Okay, then I'm going to explain what are the some examples of ontology-based data access. Okay, in order to access data, we are storing databases in system, server, and data center. By using ontology as a conceptual and domain specific view, we are accessing the information. Okay, so it deals with the complex data and as well as a heterogeneous data. Heterogeneous data is nothing but different database sources. Since ontology provides a meaningful and structured way of to interpret and interact with such kind of data. What is the relationship between two items, and what is the interpretation between users and data sources? Those things we are explaining in terms of heterogeneous data sources. So the best example for ontology based data, so data access, is nothing but healthcare. So in a healthcare domain, you need to understand what kind of diseases you are dealing with, and it is completely related to hospital setting. So medical data can be stored, patient's data, patient's records, number of different databases I'm using. I'm using SQL database, I'm using Mongo database, I'm using MySQL database, I'm using DB2 and Teradata databases. So these are the different heterogeneous data I'm using in order to extract the patient related to COVID-19, whether that patient having a virus or not, by using CNN technique, RNN technique, LSTM, and other various frameworks like Keras, TensorFlow, PyTorch, Theano, Matplotlib, Pandas, NumPy, various frameworks I'm using in order to extract a knowledge or information in a healthcare domain. That's why ontology-based data access, the best example is a healthcare domain. Then second one is e-commerce. E-commerce is related to Amazon and Flipkart. Those are the e-commerce database applications. See, you are purchasing an iPhone today through mobile, and tomorrow automatically your system is asking, would you like to purchase one more iPhone, uh, based on the opinion mining, sentiment mining, and other behavioral mining. So e-commerce concepts like what type of product, customer, review, inventory system, shipping, all the terms are related to e-commerce business. What type of database, heterogeneous database they are using, related to customer database, related to product database, related to number of employees are presented in the e-commerce and Flipkart. The relation between all the terms and find all products in a certain category with rating above 4 that are currently in stock and can be shipped within 24 hours. So this is a one kind of ontology based e-commerce application. Next, third application, research and academia. Research is a search for new knowledge, okay, and searching new element from the new database. From different databases, we are extracting meaningful data. That is called a knowledge.
Sir, I'm
Research
sorry
application.
for.
Yeah, yeah,
Excuse me, sir. Excuse me, sir.
yeah, yeah.
Yeah, I want to get one small clarification. The previous slide, sir. Can
Yeah,
I
yeah,
ask
please,
you,
sir.
sir, right now?
Please, you can ask any query, sir.
Yeah,
I'm
thanks,
ready
sir.
to explain.
Thank you, sir. Here, actually, as you are connecting this ontology concept to the patients and doctors, right?
Correct, correct,
In the view of treatment as well as medication or something,
correct, sir.
etc.
Correct. Healthcare
So
domain. Yes,
yeah,
sir.
so healthcare domain. So what I'm requesting your side, so what are the type of data sets which we are expecting from patients and doctor relation based data sets?
Perfect question, sir. Wonderful question. It's a
Thank you.
knowledge based question. Please listen, my dear participants. Give him a big round of applause to Dr. Polaya, sir. Such a wonderful question. He has related to healthcare domain. Please give him big round of applause. See, my question is, where I can use ontology in the case of healthcare domain. So SAR explained concepts like patient database is there, doctors related database is there, treatment related database is there, medication database is there. Four database, different heterogeneous database is there. And my question is, what type of customer, patients databases are available? COVID virus prediction database is there, and pneumonia database is there, and Ebola virus database is there, lung cancer, breast cancer, and diabetes database are there. Different kinds of heterogeneous databases. We are extracting meaningful, interested patterns by using statistical methods, machine learning methods, deep learning methods. My question is, find all patients diagnosed with a particular condition who are not responding to their current medication. This is the query I am posing to the healthcare domain. So without requiring knowledge of the underlying database, you cannot solve such a question. So this type of relation is called ontology-based healthcare domain. Very good, sir. Very good question. Wonderful question. Any other queries?
Sir, extensionally, I want to ask one more small
Yeah,
clarification
please, sir.
question. So actually, the data sets which you are mentioned, really
Yes,
I'm accepting and appreciation for your answers, sir. I'm thankful for that. And coming to the my small clarification, which I wanted to get in between patient and the doctor
yes,
relationship of treatment in the point of psychology aspect. So
yes,
even you may be know and everyone may know here some doctor is a psychology doctor also, right?
yes, yes.
Yeah, in their psychology doctor point of view, I may asking you your side if you know, sir, right now, or you can answer later also.
No problem.
What
I'll
type
answer.
of
I'll answer.
yeah, what type of such a psychological data sets which we wanted to get from the
Yes, very good.
doctor, maybe in terms of feeling emotion
Correct.
data sets.
Correct,
Okay,
sir. Yeah,
so how these type of psychology data sets which we can
correct.
connect to these anthologies, sir? How
Correct, sir.
we can
Very
connect to?
good.
That is
Very
my
good
question,
question,
sir.
sir. So now I have given the database list. So there is a psychology related data, doctors or data set is there. So what psychologist has done, who are the mentally disturbed patients data is collecting mentally disturbed and mentally disordered people data, is collecting from the various sources like UCI repository, Kaggle repository, GitHub repository. I am collecting the data set. What is data set? Collection of rows and columns. Columns are, you can call it as a very important items, attributes in order to form a data set. The data set is related to mentally, physically challenged people data set. What a psychologist is doing his treatment is collecting all is lagging and which areas is the confidence is less and mentally is strong or not, such kind of all the data we are collecting from the data set. Based on the symptoms, psychologist is taking a prediction algorithm. Okay, these are the symptoms and these are the things. Based on that one, a student or a patient lagging confidence. So based on that symptoms and based on that constraints, psychology is taking decision, is motivating in that direction, how a student or patient can get the confidence levels based on the prediction, emotions on the prediction database from the huge volume of mentally disordered data, physical disordered data, symptoms of the patient's data. So there we are forming ontology relationship between users like patients, between data sources. Data sources we are getting from the repositories like UCI, GitHub, Kaggle repositories. These are the free websites and repositories where you can get psychological related data set, and we are solving such kind of applications based on this ontology based data access applications. Wonderful question, sir. Dr. Polai, sir, once again give him a big round of applause. Any other
Thank you,
queries?
sir. Thank you. Thank you.
Yeah, yeah. Any other queries, my dear participants?
No, sir. Carry on, sir.
My screen is visible, sir.
Yes, sir. Visible, sir.
Yeah. So next coming to, I'm developing a research and academia ontology based application. So here you need to consider who is researcher and who is a publication. What is the publication? What is the topic? What is the citation? What is the literature survey? These are the key terms of research and academia. Now we are developing ontology based data access for this research related applications. And my question is, retrieve all publications related to specific research topic, that is healthcare domain. Okay, that have been cited more than 100 times. So what, this is the question. Now I'm collecting literature survey from various sources like InterScience, IEEE, Elsevier, and Hindavi. There are numerous papers related to COVID-19 and Ebola virus, diabetes, lung cancer, breast cancer, prostate cancer. These are the databases I'm collecting from the real-time hospitals and as well as the repositories from the UCI, Kaggle, and GitHub repositories. 100 papers I'm collecting and maintaining a database. Now, I got different databases from the different sources. Here, I am making the relationship between who is researcher, who is the publication, what is the topic, what is the citation in between relations. So that's why we are developing a fine-tune application related to research and academia application in order to maintain the relationship between researcher and publication. That is the ultimate goal, and that is called ontology-related research and academia. Any other queries, my dear students?
No, sir. No, sir.
Understood?
Yes, sir. Yes, sir.
Perfect. Then supply chain management, one more case study, one more application. How do we develop ontology-based data access application? So this is a related business-oriented application, such as there you can find concepts like who is vendor, who is purchasing, what is inventory, how many sales are happening, and what is the shipping mechanism, and what is e-commerce website you are using to shipping, whether you are using Amazon or Flipkart. Now see the four important concepts like vendor, purchase order, whether you are using credit card, debit card, or any other UPI ID, inventory system, sale, shipment. Now I am making a query like identify all vendors who supply a particular product. Now I would like to purchase iPhone. So you can see have a good delivery record and have availability in the next month. So here I am maintaining ontology relationship between past data, being data, and real-time data. That is called historical data, that is called legacy data, and current data, and future data. So now my application is which identify all vendors who supply a particular product, whether it is Amazon or whether it is a Flipkart. Now I am maintaining relationship and databases related to vendor database, purchase order database, inventory database, and sale database and shipment database. Now here I am extracting different sources, heterogeneous databases, that is called data sources. Now I am developing unified application between user and data sources. That is called ontology related supply chain management. Next, the last application case study related to data management. Now I would like to explain what is meant by data and what is meant by management. Environmental data management. Data is a raw material which can be a audio, video, text, graphics, animation, any kind of data is called data. And managing that data with help of database management tools like SQL, MySQL, Teradata, DB2, MS Access, etc. So here I am maintaining various ontology concepts like species, habitat, climate data, and pollution levels. These are the major four concepts I'm taking, and four databases, heterogeneous databases I'm taking, and I'm asking the complex query like find all species that live in a specific habitat and are negatively affected by certain pollution levels. If you take Nalgonda, Nalgonda is a famous for salty water. There you can find a number of PFAs. Okay, PFAs are salty water and hard water, that is called D2O water. Okay, so now with the help of that water, people are affecting the disease like their teeth are becoming yellowish. So because of PFAs. So that is a disease they are getting from the Nalgonda area. So now I'm using that concept in this environmental data management. Now I'm maintaining database related to PFS database, climate database because of climate, because of water, groundwater database, pollution levels database, and habitat database, species database. So that is there we are developing a ontology related environmental data management. So these are the best examples, and we are solving real-time applications. And so I have explained already what is meant by major concepts of ontology-based data access. I have explained what is a ontology. Ontology is a formal representation of knowledge. Knowledge is nothing but interested information or meaningful data or a quality data. Any language that allows for abstraction, categorization, or relationship between all the entities, that is called ontology. That is one more concept. Then mapping. Mapping is the process of linking elements of the ontology with the elements of database. So mapping is a process of creating a data with a key with element, key with value. That is called a hash table. Hash table is the process of mapping between one item to another item. Okay, key with value. So mapping is very important connection between the conceptual view, that is called ontology, and the actual data in the database. So this can be as the glue that connects the ontology to the underlying data sources. So mapping also one of the mapping means conversion of data from one format to another format with the help of users to and data sources. That is called a mapping. So mapping can be, you can do one-to-one mapping, many to many, one to many, many to one to one, various relationships between a user and data sources. That is called a mapping. This is also one of the important concept of mapping. Next major concept is a query translation. So query is a question. Translation is a conversion of one format to another form. So here I am taking high-level queries, questions written against the ontology or translated into queries that can. Okay, now I am asking the question, Ungulku Tamil Teriyama. This is a sentence I have given. Now, what is the meaning of Ungulku Tamil Teriyama? So, that I don't know. I am using translation. So, converting Tamil to Telugu. Miru Annam Tinnara. So, that translation is happening in between query. I am using the query like okay, உங்களுக்கு தமிழ் தெரியாமா means do you know English? So in Telugu you can call it as మీకు తెలుగు వచ్చా, మీకు తమిళ్ వచ్చా. So this is the data source I'm using for query translation. It involves translating from high level language like English, and such as there we are using a Spark QL that is used for query ontologies. Very popular language called a tool. Spark QL. QL means query language into a language understood by the database that is called a structured query language. I'm asking the question, do you know Tamil? It is a high level language question. Now here I'm maintaining relationship between data, database, and language database, okay, and queries database, and I am making relationship between user and data sources. That type of ontology is called query translation ontology. Next, reasoning. So reasoning is one of the factor or engine are used to infer new facts from the ontology and the data based on the defined relationship and the rules. Suppose you are developing intelligent robot like a Sophia. Sophia is a humanoid robot, but if you give key, play Sophia, it can dance. Play football, Sophia. So Sophia is playing football. Sophia is playing badminton based on rules and regulations. What are the rules you have developed based on the expert system? Expert system consists of if then rules. If the ball is coming left side, you can move and lift the ball. If the ball is coming right side, you can move right side and hit the particular direction. So this is the reasoning related a system is called expert system. So there we are developing intelligent kind of robots or voice based chatbots. Example, Siri and Alexa. Those are the reasoning based intelligent applications we are developing. That is also one of the major concept. Then data source. What is a data source? Where we are getting huge volume of data from the repositories like bank transaction data, weather forecasting data, traffic data, NASA data, Sensex data, stock market data, and healthcare data. These are the different databases from the different repositories we are accessing. That type of source is called a data source. What is the ultimate goal of ontology based data access is to provide a unified and intelligent based application in the terms of ontology based view of this data, regardless of how and where it is stored in the different heterogeneous databases. That is called data source. Data source is a one more major concept in ontology based data access. Then users and user queries. Users is nothing but customers. Customers is nothing but end users, peers, and people, etc. What sort of user is asking the queries? That is very, very important. Why, what, where, and when. These are the important queries we are generating with the help of users. That's why users and user queries are very, very important in the concept of ontology based data access. Then data visualization. Data visualization is nothing but I am developing application and finally I am showing through diagrammatic representation with the help of bar chart, pie chart, line chart, scorecards, and visual boards, signboards, etc. Principal or my manager would like to see the scorecards, map bar charts, so he can estimate this year percentage is 97 for final year. Next 2024 I am expecting 98 percentage. Such type of decisions is taken by the principal or manager or any project manager would like to take the decisions based on the data visualization. In order to generate a data visualization in Python programming, we are using matplotlib. Suppose you are using R programming, I am using a ggplot library, I am using Mahout library. Okay, and I'm using you can call it as a Tableau. Tableau is a visualization programming language. R is a visualization programming language. Okay, so this is about the data visualization. So what are the detailed process of ontology based data access? So ontology development by using web ontology language, that is called OWL and RDF, and various users and databases relationship between various languages and vocabulary you are using, and what are the major concepts involved in the development application. You need to have knowledge. Then mapping creation, I have explained already mapping. So mappings are created between the ontology and the underlying data sources, users and between users and data sources. So we are developing a number of queries written in terms of ontology into queries over the actual data source. So based on our requirement, we are creating a mapping between user and different data sources. Then query transformation. So query transformation is nothing but we are transforming one form to another form. So here I am taking a high level language like Spark QL, that is query language for a relational descriptive framework, that is RDF, a standard model for interchanging on the web related applications or development. So what query translation is done, I am asking the query with help of a Spark QL, which is related to structured query language. So it is related to relational database framework, description data framework. So it can translate a high level language to low level language, and whatever the required format you would like to convert one file format to another file format, one query to another query format. That is called a query transformation. Then final one is a data access. There are a Shankars are asked a wonderful question. How many access methods are related web technology? How many access methods are related to artificial intelligence? How many methods are related to SQL, MySQL, Teradata, DB to MS Access? How many data access methods are related to NoSQL databases like Mongo database, Hive and HBase database, etc. So that is related to data access. Okay. Then I have explained already the role of ontology. So the role of ontology is a vital role in order to develop unified applications or intelligent based application. It is acting as an interface between users and the data sources. That is a role done by the ontology. Then data source. There are multiple databases are available in the real-time environment, like XML database, HTML database, SQL database, MySQL database, DB2 database, healthcare database, audio database, video database, YouTube database. What are the sources and where we are getting these sources? Yes, sir. I am getting these databases from the repositories. Like a YouTube repository, I'm getting streaming data. From a UCI repository, I'm getting the healthcare data. From Kaggle data, I'm getting image databases of COVID-19 X-ray images, CT scan image data source. And I'm getting GitHub, I'm getting a diabetic database, text data, and image data, and as well as audio data, video data. So these data sources I'm getting from the various repositories like UCI, www.uci.com. That is one repository data source. And one more is www.kaggle.com. That is one more repository. www.github. That is one more repository. Then the third one is mappings. Mappings already I have explained. Okay. Creating a map between user and a data source, customer and a data source, creating a map between different sources, data sources, corresponding elements, corresponding concepts. Mappings are translating Spark QL to RDF through SQL, structured query language. That is called a mapping. Create mapping of healthcare domain. I am creating mapping between patients versus doctors. That is the mapping I am doing in the ontology-based data access. Then query transformation and execution. So I'm making query with the help of Spark QL, which is the standard query language for relational description framework. And ontologies, I'm making one format to another format with help of user understandable format. And finally, we are executing through that query. I'm getting the correct answer, correct ontology. That is called execution. I am going to execute various Spark QL to RDF through SQL in Python programming. Today I am going to give you two important practical oriented applications, okay, by using Spark QL through RDF and with the help of SQL. So that is called a query transformation and execution. Then what are the foundational concepts? we have a foundational concepts I have explained already. Databases. What is meant by databases? Collection of interrelated data in particular domain, health data, stock market data, and weather forecasting data, etc. And ontologies, what are the relationship between users and data sources. And semantic web means intelligent meaningful data with the help of web technologies like HTML, XML, and cascading style sheets, and we are using different web technologies languages. So in these foundational concepts, I have explained the data access methods. Okay, there are two types of data access method we can see in the real-time environment. One is relational database languages like SQL, MySQL, Teradata, DB2, MS Access, and Hive and H-based databases in order to access XML file or any kind of data you are accessing. Then ontologies I have explained, and the semantic web technologies also I have explained. So what is meant by RDF? RDF is nothing but resource description framework, where you are getting resource. So you are getting UCI repository, that is called a data access, where you are getting audio video data through GitHub and Kaggle database in order to represent that data in the form of RDF, that is called a standard model for data interchange on the web level. That's why we are using a OWL, that is called a web ontology language. It is a language for defining and instantiating web-based ontology. This is intelligent kind of relations we are extracting and maintaining a knowledge from the web databases. Then a Spark QL. It is a query language for resource description framework. So Spark QL is a query language like SQL, structured query language. MySQL, that is a product of Microsoft company. SQL is a Oracle company. DB2 is a IBM company. And Teradata is a Teradata company. Like that, we are maintaining different Spark QL database languages. Okay, so then mappings is a one kind of creating a mapping between user and data sources. I have a data sources, various data sources. I have web related data and healthcare data, stock market data, and educational data. I am mapping between student and faculty. A mapping between employees versus IARE, in Institute of Aeronautics employees organization mappings. You can do one-to-one mapping, many-to-many mapping, one-to-one mapping, one-to-many, many-to-one. These are the mappings we are creating. Then query transformation. I have explained already query transformation. Data integration. Data integration is nothing but multiple data sources, multiple databases we are creating and performing. Okay, relational database or non-relational database. It is related to ontology-based data access scenarios. Data integration is nothing but multiple data sources and integrated in order to solve a unified view of the data and developing web applications, call center applications, business intelligent applications. We are developing data integration. So this is the diagram. If you see, so I'm developing target ontology application related to suppose web related application. So here I'm using number of questions, queries, and the sources, where source database consists of UCI and Kaggle and GitHub repositories. Then source database I'm getting different multiple data sources I'm getting. And I'm getting a ontology web language, Spark QL query language, like where and relational relational to relational machine language tools are available in the case of ontology based data access. So this is called a web ontology language, is the uniform conceptual federated model. Model is nothing but simplified version of the reality. Then the fourth concept is introduction to data source for ontology-based data access. What are the data sources? I have already explained enough data sources like we have relational databases with help of SQL, MySQL, Teradata, DB2, MS Access with help of schema, with help of procedure syntax, we are creating the database. That is called a relational database. We are creating tables. Collection of tables is called a database with help of RDBMS. That is called a relational databases and NoSQL databases. There is no schema, there is no table, there is no syntax, but I am creating the database for audio data, video data, and etc. By using NoSQL databases like Mongo database, Hive database, HBase database, Cassandra database. Do you know any one of you? Facebook uses database is called Cassandra last year. But recently, they have shifted Cassandra to Hive database, data warehouse tool, because Cassandra not performing very well like queries like joins and triggers. These are the two concepts is unable to solve Cassandra data warehousing tool. That's why Facebook company shifted to Cassandra to Hive and HBase. Now you can check in the Google, Facebook maintaining database is called Hive and HBase. And Facebook also uses graph databases. There we are using language called Neo4j, because collection of nodes in a network format is called Facebook. There is a server contains number of clients, each client is called a node. Number of nodes are connected to client server communication, whereas in Facebook collection of nodes is nothing but number of CSIT students are connected to CSC department HOD. That is mapping. With the help of Neo4j, I am developing NoSQL database with the help of Cassandra, Mongo database, HBase, and Scoop, etc. Okay, next XML and JSON document. So extensible markup language data and JavaScript related formats, and it is commonly used for data over the web. These are the web programming languages, and we are using map to ontology using appropriate mapping languages. So here I am taking different web technology languages, different database languages. How do I can interface between users under different databases like XML database, HTML database, and RDF database, SQL database, MySQL database, etc. Then web APIs and web services. APIs stands for application programming interfaces. If you take a web APIs of Java programming language, we have various APIs. Libraries, packages of Java. Can anyone?
Serverless, JSP, so many
Correct.
applets.
Correct, sir. Any other web-related APIs we are using in order to develop business applications and web-related applications? Please, can you list out? Yeah. JSON, XML, and even in Java, extension Java, we are using applets, AWT, swings package.
Yes, sir. Yes, sir.
There are various APIs we are using in Java. If you take in Python, we are using APIs like Keras, TensorFlow, Theano, PyTorch, Matplotlib, NumPy, SciPy, Scikit-learn, sklearn. These are the various APIs and web services we are using in this Java and Python programming languages. Okay, so these are the which can map to the ontology related web related applications. Then semantic web resources like resource description framework and ontology web language. So these are the various sources like RDF triple stores, and Spark QL endpoints can also be directly linked with the ontology. So these are the data warehousing. Data warehousing is nothing but storing of huge volume of data through data cubes. That is called data warehousing. Collection of data marts is called data warehousing. Data mart is a storing of small amount of data in the server is called a data mart. Collection of data marts is called a data warehousing. So data warehousing, sometimes we can call it as a online analytical processing. Okay, so there are tools like data warehousing tools. Informatica, you know Informatica, it is a data warehousing tool. There we are performing various transformations like aggregate transformation, sum transformation, total transformation. There are various transformations we are using in a data warehousing tool. Then that is called a data warehouses. So open, you can call it as a OBDA, ontology based data access databases, web related data warehousing, and health related data warehousing, and you can semantic web related data warehousing, student data warehousing, IARE, Institute of Aeronautics Engineering database. That is, we are storing in the servers, high computing servers. That is called a data warehouses. Data warehouses is called online analytical processing. Any doubt? Then file systems and data lakes. File is a collection of related data. There are two types of files we can see: sequential files and random access files. And you can classify into number of file systems like permanent files, temporary files, random access files. Then what is meant by data lakes? So these data lakes are having unstructured file formats it can handle, and the data can be realized in case of ontology based data access systems once it has been transformed and structured appropriately. Conversion of structured to unstructured format, unstructured to structured format, such kind of information is called data lakes with the help of Spark QL and RDF and SQL. So this is about you can have it. These are the introduction to data sources we have completed. Then what are the advanced topics we are studying in ontology based data access? So advanced concepts is nothing but we are using scalability. Scalability is nothing but increasing the size of the data, and automatically we are increasing the server, data center, hard disk capacity. So scalability says that the size of the data increasing day by day in the system level, server level, and data center level. See why Gmail giving 24/7, where is the Gmail server is presented, data center is presented, San Francisco, USA. If you wake up at midnight 2 o'clock, Gmail is working 24/7 because of cloud environment concept is presented. Okay, so your user ID is one of the instance of the data center. That is called a client server communication technology. So number of users are increasing because free registrations in the Gmail account. Definitely Google, they are increasing their data center capacity. That is called scalability. Next, expressive mapping. See, we are creating mappings like one-to-one mapping, many-to-many mapping, one-to-many mapping, many-to-one mapping, based on the ontology concepts, based on the index terms, based on the queries, complex queries. It is involving designing a more expressive mapping languages we are using, and studying their computational properties is called expressive mappings. And the third one is a advanced concept like a handling of incomplete and uncertain data. Which data is called incomplete data? Suppose I am taking CSIT students data. See, I have read the record like name equal to Ramesh and age equal to 17 or 18, and branch equal to CSIT, and pass or fail target class. So suppose salary I kept minus 10 rupees. So all the columns are showing correct data, but the target class salary is a minus 10 rupees. It is a inconsistent data. How system will read minus 10 rupees salary? Incomplete data. That is called incomplete data. That's why we are eliminating redundant data, noisy data, inconsistent data, dirty data by using pre-processing techniques like box plot, binning, and various filters we are using in order to remove the redundancy data. That is called handling of incomplete and uncertain data. Suppose the data set you are having all null, suppose some zero values are there, some minus values are there. How do you process? I want to make it whether positive values. Then I am keeping, instead of minus one values, I am making it as a null values. Okay, or I am making as a all zeros, so that remaining values we can perform a total, average, standard deviation, various statistical operations we can perform. So that type is called uncertain data, incomplete data. Next advanced concept is a temporal and a spatial data. So temporal data means seasonal data. Suppose every 6 months I am getting such type of data. Suppose mango data. Every summer season I am getting mango database. What type of varieties of mangoes are available? Okay, so spatial data, which is related to stock market data and weather forecasting data, that is called a spatial data. We are extracting meaningful, interested patterns from the huge volume of temporal and spatial data. Then fifth one is a machine learning and ontology-based data access. So learning from the observational data, okay, and by using various machine learning techniques and machine learning tools and techniques in order to solve ontology based data access. That is the latest concept we are using, ontology based data access. Privacy and security means wherever data is presented, security is a problem. In order to maintain security, we need to use security algorithms like DES, AES, Diffie-Hellman problem. There are various security algorithms we are using like belief logic and high security algorithms in order to protect data from the server and system data center from intruders, criminals, and attackers, malware attackers, etc. So that is called privacy and security. That is also one of the advanced concept we are integrating with the ontology-based data access. Then streaming data under OBDA. Streaming is nothing but flow of data between system to server, server to system, server to server, system to server. Flow between one end to another end. One system to another system is called streaming data. Best example is YouTube data and stock market exchange data, okay, and traffic data. These are the examples of streaming data. So how do we extract streaming data? With help of streaming data mechanisms, that is called data access methods. Whether it is audio based related data access methods, whether it is image based data access methods, it depends on the application. We are solving prediction algorithms, classification algorithm, and outlier detection algorithms, and malware detection algorithms, etc. So next, eighth one is debugging and validation. Debugging is the process of eliminating errors, mistakes, bugs in the program. Program is a collection of instructions. For debugging is a process of eliminating errors and mistakes with help of compilers like Java compiler, Python interpreter, etc. Okay, so if you are using Python or Java based on the compiler, based on the interpreter, we are solving, we are eradicating mistakes, we are eradicating faults and mistakes. Then finally, we are checking with the validation metrics like precision, recall, F1 score, etc. Then the last advanced concept is usability and user interface, where we are using this ontology-based data access methods, tools and techniques, databases. That is very, very important for in the case of users. And what is user interface? How this ontology acting as an interface between user and the data sources. Okay, so that is the latest concept of usability and user interface. So these are the any doubts, my dear students?
No, sir, you carry on, sir.
Sir, how many students are there? I'm explaining continuously theory, sir.
Oh, yes, 39,
Feel,
sir.
see, only 39 students are there. Why they are decreasing, sir?
So
I'm not
actually,
understanding.
47 members came, sir. Suddenly they left the group. So again, they will add, sir. Maybe technical problems, technical issues,
Okay,
and
okay.
internet
So
problems.
no problem, sir. Any doubts?
So
Any
actually,
doubts? Even faculty members,
so
please
actually,
ask me any doubts
oh yes, sir. So
and
I have
any
one doubt,
queries
sir.
related to ontology-based data access. If no queries, I can switch to next concept, sir.
So what is the role of big data in this data access, sir?
Very good question, sir. Sir, which data we can call it as a big data? That means the traditional systems are unable to process the data, unable to solve the computations. That's why we are going for big data processing tools like Hadoop, Spark, MATLAB, or Python, Hive, and HBase to solve complex databases. So, big data is going to play vital role in this ontology-based data access. The terms like you need to have knowledge on the databases like what kind of database you are handling, whether it is a healthcare database, it is a big data, and what are the dimensions you are using in big data, volume, velocity, variety. What are the big data tools you are using? Hadoop, Spark, Hive, HBase. What are the technologies you are using? You can Scala programming, Java programming, Python programming, and R programming. Then these are the concepts we are using and developing ontology base related to big data in order to solve complex database applications by using statistical methods, by using machine learning and deep learning techniques that is related to ontology based big data ontology based application. Shankar sir,
Ah,
is
yes,
it?
sir. Yes, sir. Okay, sir. Sir, other doubt, sir.
Yeah,
One
please
more, sir.
ask me, sir.
Sir, how the e-commerce websites, how they accessing data efficiently? What are the other technologies are they using for efficient data access? Efficient data access is very important to them. So, other than this ontology, what are the other kind of technologies those e-commerce websites using for efficient data access, sir?
Very good question, sir. So, what are the e-commerce databases? We have Flipkart and Amazon.
Yes, sir.
Okay, sir. So these are the e-commerce websites. See, so you doesn't have permission to access the Amazon database because until unless you have to take the permission from the CEO of Amazon and Flipkart. So those are the commercial websites. They are not revealing their database. Only employees are having the permission to access data access methods. There are n number of data access methods through SparkQL, SQL, and RDF, and other Python programming, Java programming. There are methods, various methods. If it is audio, video based, and product based, access methods are available. Once you have a permission from the e-commerce websites like Flipkart and Amazon, then we can have efficient retrieval of data in terms of ontology database related. There are n number of methods, sir, we are using.
So will they use machine language, artificial intelligence for efficient data access, sir?
Yes, 100% suitable answer you have given. Yes, sir. They are using intelligent kind of prediction algorithms. They are using like linear regression, non-linear regression, logistic regression. They are using prediction algorithms in machine learning, support vector mission. They are using random forest. They are using Bayesian classification, and and they are using k nearest neighbor algorithm, etc. And they are using a few more clustering algorithms like k-means clustering, fuzzy c-means clustering, and various unsupervised learning approaches like even clustering methods like PCA, principal component analysis, also comes under artificial intelligence, machine learning, and deep learning methods like CNN, RNN, LSTM. They are using in order to retrieve efficient and meaningful data, knowledgeable data, and prediction related to particular application. Very good question, sir. Shankar, sir.
Sir, shall we use neural technology for this data access, sir?
Yes, very good, sir. We are using neural networks for classifying the data, prediction of the data, and KNN, K nearest neighbor. These are the fundamental concepts of convolution neural networks, recurrent neural networks, and long short-term memory frameworks, Keras, TensorFlow, PyTorch, Theano, Matplotlib, various frameworks we are using in order to solve various applications, streaming based applications, database applications, etc. Very good, sir. Very good question.
Sir, one more doubt, sir.
Yeah, please.
What are the disadvantages of this Ontology-based data access, sir? Is there
Yes,
any?
very good, sir. So, disadvantages, you can see various disadvantages I have mentioned. So, while creating ontology with the mapping creation, sometimes if we are not defining very good concepts closely related to particular domain, the mapping will fail. If you create a wrong mapping, it gives wrong output. That is one disadvantage, Shankar sir.
Okay, okay,
And
sir.
yeah, and one more is maintenance. Maintenance is a one of the drawback of ontology-based data access. You have a suppose you are maintaining a database, SQL database and MySQL database with help of tables. And suppose you are maintaining audio database, video database in with help of NoSQL database. Suppose if you are not using the triggers and joins concept properly in the relational database, you cannot retrieve for the particular query, and you cannot solve non-trivial task in that query language. That's why if you maintain SQL data, relational database, non-relational database in the data warehouse, if you are not maintaining joins and triggers and concepts mappings, then definitely there is a problem occurs while maintaining the database. That is also one of the drawback. And performance. Suppose you are using a small server for computation power in order to solve a classification, clustering, outlier detection in the case of cyber security threats. My system is not performing well. That's why we are moving towards cloud computing environment, because it can solve complex queries and complex database because high computing power is there. That's why performance playing a vital role in terms of system level performance, server level performance, and data center level computing performance. Then the next drawback is data quality. So if data is a dirty data, you are giving input to the system, you are expecting dirty output only. If you are giving incomplete data, you are giving as input to the system, you are getting wrong output only. So data must be a quality. That's why in order to make the quality of the data, we need to do pre-processing, removing the noisy data, inconsistent data, dirty data, incomplete data, etc. By using box plot technique, binning technique, and major filters. Filters we are applying. So the data becomes information. So data quality is one of the drawbacks. Next, limitations of ontology languages. Whether you are using a web ontology language properly or not, related to Python, related to Java, related to RDF, related to SparkQL. Which language you are choosing in order to develop the particular ontology healthcare related application, that is a challenge once again, and that's why it is a limitation of ontology languages. Then flexibility of schema is a relation, schema is a procedure in order to create a table in MySQL, Teradata, DB to MS Access. So if you are not using particular schema, if you are using a star schema, snowflake schema, in the case of storing data with help of data cubes in the data warehousing, there is a problem once again in order to store multidimensional databases. So if you are not using a particular correct schema, it gives a problem. That's why it is called a inflexibility schema, especially in relational database tools. And training. So training is a one more limitations of ontology-based data access. Suppose you are using 1 terabytes of hard disk, but you are running with the 2 terabytes of application, but your system unable to process the training data set because of limitations of computing power. That is training also a one of the drawback while performing a complex application in terms of CPU processing. Then limited tool support. Sir, I am solving the ontology-based healthcare application, but I am unable to choose the Python tool or Java or R programming or MATLAB or any kind of Spark, QL, RDF, SQL, MySQL. Which tool I have to use? I'm confusing based on the application, based on the constraints, based on the limitations. You need to choose the best tool for solving. That comes by experience, that comes with the practical experience. You can choose best tool. That is also one of the limitation. Then the last one is semantics. So misinterpretation. That means you got a final output. Suppose you are taking COVID-19 X-ray images as input, and you have done excellent application, virus prediction and detection. So you got the results positive, negative, and some images are not classified correctly because of misinterpretation, that my model is unable to predict that the chest X-ray image is completely disturbed, completely spoiled. It is not clarity. In that case, my model is unable to classify the data, whether it is positive or negative. Such kind of data we are doing misinterpretation sometimes. So there is no meaning of unclassified chest X-ray images. That is also one of the drawback. Very good question, sir. Shankar, sir.
Thank you, sir. Sir, one more doubt, sir. Shall we use this ontology?
Any other queries, my dear participants? So I am giving please see here, my dear students and my dear participants. So I am giving the assignment questions. Please, any other queries, please listen. These are the case studies. Healthcare and life sciences case study, supply chain management, smart cities, environment monitoring, finance and banking, aerospace and defense. And projects like ontology-based data access, the optic project, Bio to RDF, linked life data, the semantically interlinked online communities, that is one more project, and the open biological and biomedical ontologies foundry, the database PDA project. These are the projects of OBDA. These are the assignment questions. Sir, I am giving these assignment questions in the chat box. Please circulate to the students and let them come with the answers. Tomorrow I am expecting assignment from them, sir.
Okay, okay, sir. Okay,
Please
sir.
circulate. I am giving the questions here.
Okay, sir.
These are the questions. Total 15 questions I have prepared, sir.
Okay,
Please
sir.
circulate them. Tomorrow they need to show, not tomorrow, day after tomorrow, whenever they are coming to college, they need to bring hard copies of 15 questions.
Definitely, sir.
They will give, you can give certificate and as well as any prize amount who are performing very well in this assignment, sir. Please.
Definitely, sir. Definitely, sir.
And I am going to demonstrate tomorrow various applications, various projects by using Python programming, sir. Any doubts, sir? Let them ask, sir.
Okay,
My
okay,
dear
sir.
students, please. My dear students, can you answer these 10 questions? Okay, wait. I'm asking the 10 questions so that whether you understood or not my subject today. Okay, please answer. Please give me answer. Unmute all, sir, please.
Oh, okay, sir.
Please unmute all. My dear students, my dear participants and faculty, you can also give the answer for these questions. I have prepared ontology-based data access. The first question is, what is an ontology in the context of OBDA? Please see the first answer. A type of database, a high-level conceptual model of a domain, a mapping technique, a data storage system. Can anyone give an answer in the chat box? I can check. Please. Please. Can I see answers from the
Sir,
chat box?
Grishma said B, sir.
Yeah, please. My dear students, let me check your answers. What is the correct answer you are performing right now? What is the answer for this query? Can I give answer?
Yes, sir. Actually, I think C, sir.
Yeah. 1 second, sir. So you can see the answers. The answer is a high-level conceptual model of a domain. You are correct. Give her big round of applause. Next, second question. In ontology-based data access, mappings are used to, first option, convert data into different formats, define how data from the sources can be transformed into instances of the ontology, C, restrict access to data, D, optimize query execution. Can anyone? What is the answer? Please. Can anyone? What is the answer, sir? Please check, sir. Shankar, sir.
Sir, is it A, sir?
Please check, students have given answer for that one or not, please.
No, sir. No one responded, sir.
Yes. Mappings, I have explained
Yes, sir.
many times what is meant by mapping. See,
B,
it
okay.
define how data from the sources can be transformed into instances of the ontology. Okay, the relationship between, and we are creating mapping between users to different sources. That is the B answer, correct answer. Only one or two students given a correct answer. Then third question, sir. Shankar, sir,
Okay,
please.
sir. Okay.
What types of data sources can be used in OBDA? First question, first answer. Only relational databases, only NoSQL databases, only XML and JSON documents, and all of the above. Any
Sir,
answer, sir?
sir, some students responding, sir.
Grishma,
Akil and Mallikarjun and Grishma responded,
perfect
sir.
answer.
Their answer is D,
Grishma,
sir.
Akhil,
Sir,
Ravi,
D, sir. Sir, D.
Perfect answer. Perfect. You are all are outstanding students. All of the above. Next, fourth question, sir.
Yes, sir.
Which of the following is an advanced topic in OBDA? I have explained all advanced concepts. Can anyone? Option A, scalability. Option B, handling incomplete and uncertain data. C, temporal and spatial data. D, all of the above. Anyone?
Sir, Sharma is saying A is the answer, sir.
No, sir. Wrong answer.
Sir, D.
Any other?
One more
Shankar sir
student.
saying Grishma, you are wrong answer. Why you are saying B answer? What about remaining answers?
Sir,
Please check.
Sir, D. Sir, D.
Shankar sir is saying D answer. It is absolutely correct, sir. So these are the three advanced topics in ontology-based data access: scalability, handling incomplete and uncertain data, temporal and spatial data. Very good answer, sir. Fifth question. In ontology-based data access, why is ontology used as an interface between users and data sources? Please see the answers. To provide a unified view of heterogeneous data sources. Next, B. To allow users to query data using domain-specific terms without needing to understand the underlying database schemas. And C, to provide a more efficient way of storing data. D, both A and B. What is the answer, my dear students?
Sir, option D.
Option B, correct. And check one more answer also correct.
Sir,
Yeah,
D, sir, option D.
sir.
D.
You told D answer, both A and B. Correct answer.
Atil saying D, sir.
Yeah, D is the correct answer, sir. Wonderful answer. Give them big round of applause. Next, sixth question. In the context of OBDA, what is the role of machine learning? Shankar sir, your question came.
Yes, sir. Yes, sir.
The option A, automatically generating mappings, correct? Predicting the performance of different query answering strategies. C, providing a semantically rich interface to data used in machine learning. D, all of the above. And Muhammad, you are given wonderful answer.
D, sir.
Thank you, sir.
And
Option D.
Bharat Kumar, you have given wonderful answer. Very good, Nana. Very good. Keep it up. Next, seventh question. What is a key challenge in handling temporal and spatial data in OBDA? So extending the challenges means limitations, issues. Extending the answer A, extending the ontology languages to handle temporal and spatial constructs, devising efficient query answering techniques for such data, ensuring data privacy and securing both A and B. Please tell me the answer.
Sir, option D.
Option D, both A and B. Wonderful answer. Who is that? Shankar sir.
Who is that student? Say the name
Sir,
and
alternate.
Wonderful answer. Please keep it up. And the last question. Please answer. తాగుతున్నాను. Which of the following could be a measure to handle scalability in OBDA?
sir, Muhammad saying that option D is the correct, sir.
Any other students? Please answer to my question.
Sir,
Which of
option
the
D.
following could be a measure to
Say your
handle
name. Who is
scalability
that?
in
Who is that
OBDA?
saying answer?
Materializing a certain inferences, using advanced indexing, employing parallel processing. D is the correct answer, sir. Wonderful answer.
Yes.
Who said D answer, sir?
Muhammad, sir. Altaf
Muhammad.
Muhammad.
Give him big round of applause to Muhammad. Keep it up, Nana. Wonderful answer. So please note down questions. Please note down any queries you are having. Please ask me any queries, my dear students. Please ask me any queries. I am winding the session, and tomorrow we will see the all practical oriented projects. I am going to demonstrate the projects, practical implementation, my dear friends.
Dear students, any doubts?
Any doubts? See, 7 and 15 questions I have given. Tomorrow, I mean Monday, while coming to college, Shankar sir,
Yes, sir. Yes,
please
sir.
expect from them 15 questions as assignment.
Okay.
They need to submit because you are maintaining a file for this international workshop. There you can take, we have conducted assignment for the students, 15 questions for 5 days training program, and collect all the proofs and maintain in the database.
Yes, sir.
Means
Definitely.
file. Please,
Yes, sir.
please collect 15 questions assignment, sir.
Yes,
I,
sir.
I will verify your file, sir, whether you have kept all the 15 questions assignment in the your NAC, NIRF and NBA NAC file, international workshop file. I'm going to verify, sir, with help of coordinator, Polaya, sir. They are
Yes, sir.
submitting assignments.
Definitely, sir. We keep these questions, sir.
Yes. No, at the last,
Yes.
feedback and assignment you can keep in the file, sir.
Yes,
That
sir.
will be good and show in front of experts.
Yes, sir.
We have conducted a assignment for the students in the
Definitely.
5-day international assignment questions. Any queries, my dear participants, please?
Dear faculty members and students, any more doubts?
Sir, please take feedback from the students. Let them speak because whether I am speaking fast or medium or slow, whether they are understanding my concepts or not, please let them speak 1 minute, sir, each student.
Dear student, did you understand today's session? Say yes or no. Please respond in a chat box. Did you understand today's concept?
Yeah.
So,
And
Ravi responded yes, sir. So many students responding yes, yes. Akhil
okay,
responding yes. Bharat
okay,
Kumar responding yes, sir. So it seems they
okay.
understood today's session.
Yeah. Any student can you can speak 1 minute.
So
How do you
Akhil,
look at
our
this
student Akhil,
ontology-based data access?
sir, shall we end the session, sir?
Yes,
Our,
sir. Please.
our student Akhil is waiting to give the vote of thanks, sir.
Yeah, yeah. Please.
Shall we give him the
Yeah.
chance,
Vote
sir?
of thanks. Yeah.
Akhil,
Please.
Akhil, student Akhil, you say vote of thanks, Nana.
Akhil, you can speak. Akhil, Mr. Akhil. Yeah. Speak loudly. You can speak. Do you like Dr. Asadi lecture? Akhil. And give a vote of thanks. Your Shankar sir is asking.
Akhil, turn on your speaker and speak something. Give the vote of thanks.
Maybe he didn't prepare or it seems, sir.
So actually, these are first year students, sir. They have some.
Yeah. You can give vote of thanks, sir. No problem.
Akhil, your voice is audible only, not audible. You say loudly. So he is
Yeah, yeah,
trying,
please.
sir. It seems
Yeah, yeah,
Akhil is
please.
trying.
Akhil, give vote of thanks.
Akhil, increase your voice, no, not audible. Your
Very
voice is
slow,
not
Nana.
audible.
Very slow. Your voice is. Yeah. Now speak.
Good afternoon, everybody.
Yes.
Yes, very good. It's audible now. You can
Yes.
say that vote
Please.
of thanks.
Correct.
Okay, sir. Good afternoon, everybody. On behalf of the Department of Information Technology and Computer Science and Information Technology, I stand before you with a heart filled with immense gratitude and appreciation for making the workshop on fundamentals on ontology-based data access a grand success. First and foremost, I extend our sincere thanks to our esteemed speaker, Mr. Dr. Asadi Srinivasulu. Your insightful and informative presentation has provided us with a comprehensive understanding the ontology-based data access. Your experience in the subject matter has enlightened our minds, and we are truly grateful for the knowledge you have shared with us today. I would also like to express our profound gratitude to Mr. Dr. Polaya Bodja and Mr. B. Sivasenkar, the coordinators of this workshop. for dedication and meticulous planning that made this event a resounding success. Our heartfelt thanks to go out to the faculty members of IT and CSIT for their constant support and encouragement in organizing this workshop. To the students and faculty of IT and CSIT who actively participated in this workshop, we extend our thanks to your enthusiasm and eagerness to learn have they contributed to the vibrant atmosphere of knowledge sharing during this event. In conclusion, empowered with valuable insights
2
from this
minutes.
workshop on ontology-based data access, we are better prepared for the evolving technological challenges and opportunities. Thank you and one and all for your active participation and contribution to this workshop. Thank you and have a great day, sir.
Excellent, Akhil. Very good. You did wonderful job.
Yeah.
Okay.
That's all, sir.
That's all, sir.
Can we wind up?
Yes, sir.
Yes, sir. Thank you, sir.
Thank you, sir.
I'm sharing the PPT and
Case
to your
studies.
coordinator,
Yes,
and
sir.
you can have it, and you prepare 15 questions assignments.
Yes, sir.
Okay?
Okay.
Okay, sir.
Okay. That's all from my side. I'm winding the session.
Okay, sir. Thank you, sir.
Okay.